Okay. And I'm going to go back and share the agenda with you. Okay. Okay, so it's Wednesday, 10:21. We'll review homework on chapter 4, lesson 4, 5, and 6. Anything you have, then we'll do the lecture, and then we'll do the lab part, okay? The lecture, there's a lot of stuff in this lecture, and we'll hit the high parts of it, okay? The rest of this course, it's going to be accelerated. There's a lot of stuff that's clumped together, so I mean, they simplify a lot of stuff. So I'll try to I'll hit the important things, and what I say is important, okay? So stop sharing that. And does anyone have any problems that they want to go over? Is it helpful to have the answers in the back? And is there enough information there so it's understandable to you or not?
Sometimes.
Sometimes? Probably, that's probably a good answer sometimes, because probably sometimes it's not. It's not.
Well, sometimes they don't tell you how they got the answer. They just give you the.
Gotcha.
Yeah.
Well, then if there's something like that we want to go over, please bring it up, and that's what we'll go over it. Okay.
Yeah, I had one, which was number 5, and then when I went back, because I didn't know how to do the, I think it was the median.
Okay.
But then when I looked back there, it said it was like 101.81, so I was confused. How the hell could that happen? But then when I saw on the back, you subtract those two and then divide it by 2, and so that's how I figured out what they were doing.
That's because you had an even number of data points, and that's what you have to do. You have to take the middle between. If it was 8, you'd take between 4 and 5, and then add it together, divide by 2 to get the median, right?
Yeah, so sometimes the stuff in the back help.
Okay.
Because I had no idea how you got between 97 and 106, and so when I saw you subtract it and divide it.
Okay.
Oh yeah, it made sense.
So it does make sense. So is there any of those that you want to go over right now, though? We can still do that.
So you were talking about number 5 on page 291. Is that what one you were talking about?
It was on the mean, median, and mode one.
Yeah, that's what I could not figure out how they got 101.81.
Okay, well let's go over that.
Yeah.
So 281, I think I've got it right here.
Because I'm with you. Sometimes they'll explain it, and then other times they just give you the answer. And I sat there for a while trying to figure it out. And
So which this is on page 291?
Yeah, 291, number 5.
Number 5, grocery bill for 4 weeks. Okay. And okay. So it's just those 4 data points. So yeah. Let me get a white. I gotta write this down and then go to the whiteboard here. 97.48, 106, 13, 110, 98.
So what I did was the 106.13 minus 97.48, took that and then divided it by 2, then added that, and that's
that's exactly what you do.
That's how you. Okay, I knew you had to minus it. After that,
that's exactly what you do.
Okay.
So yeah, I mean, it's important to understand that. So you just take those 2 middle terms. The middle 2 terms were 97.48 and 106, right?
13, right. 106.13.
Yeah, 13.
97.4, just a minute. And 106.13, right. And these are the 2 middle ones. I don't care about the first one and the last one. There's only 4, so it has to be the median of that, the average, right, what's in the middle. So then it just becomes 106 minus 13 minus 97.48, and you're going to take the whole thing And you're going to divide by 2. Divide by 2, right?
Good boy.
Or you can do this a couple ways. You could take you could do it this way. And divide by 2 and you're going to get the same answer.
Yeah.
Right? If I added these together, divided by
Oh.
2, that's going to give you the middle right there.
Oh, I didn't.
That makes sense?
Yeah, it does now. I like that
Easier.
way.
Yeah, it's easier.
Yeah, that way's a lot easier, huh?
Yeah, it's
Okay.
one less step. Yeah.
I like that.
So whatever that comes out to, I don't, important thing is you know how to do it. Right? Okay.
On page 295,
Okay.
I had trouble with number 3 as well
Okay, let me look
because
at
I could not figure out.
291, just a minute.
I couldn't figure out what numbers to actually use.
For number 3.
I don't know if I'm the only one that has a problem with that.
Okay, so yeah, let me go to the graph.
Okay.
292. Okay, just stop sharing. I'll share.
Is that the one where they had all the temperatures?
It's for the flu. For what percentage of flu cases was reported to the CDC during 2012 and 2013?
Right.
Well, I can see it, and I mean, I even used, something to make sure that I went straight across. And it's between 8 and 10, and I just have a hard time, figuring out what exact numbers am I supposed to be using.
Sure.
And then again,
Yeah.
the percentage thing
Okay, well,
yeah.
approximately what percent of flu cases was reported in 2013 during this time period of December 9th to January 5th? So this is the histogram right here. And so you're going to look between December 9th to January. So December 9th is right here to January.
So December 9th was really easy. That's 8.
I see what you're saying. Yeah.
But then, December 23rd, and I don't know what.
Well, you got, just take a straight line.
I did. And I mean, I would assume that would be 8.5. I don't know.
Yeah, I see what you're saying. So let me see, approximately what percent of flu cases are reported? So we're just adding them up. So we know so you're going to take the 8 and then you're going to add it to it looks like 9 for the next 2 weeks would be 9, right?
I thought that as well, but then look at the next one over. That one isn't quite 10, so I would think that one was 9. That's why I got confused. I was like, so
no, that third, well, I think that one over there, I would say it was 9.5.
9.5. Okay, so
Yeah,
9.
try that. Try 2 9s, a 9.5, and an 8. 2
Okay.
9, 18, 26, 36, 35. So I think this is 36. You see, look at the answers, Raisha.
Okay.
It's got to be 36.
Right.
Right?
Okay. Yeah,
So-
because it was 36.5.
Yeah, so don't make it any more complicated than that. Even if you're off by a little half, it doesn't matter. That number is
Okay.
still closer to that one, right?
I thought I had to add up those and then divide it, or.
No, you just add them up. No, all you do is add them up.
Okay, got it.
Because that's what this is. It's percent of total flu cases by week, right?
Okay.
And so
Yeah.
you just have to add them all up. That's all
See,
that
I
means.
just make it harder than what.
Yeah, you are. Yeah.
I'm good at that too.
Okay.
So bad.
Very good at that.
Yeah, don't make it any harder than that. Okay.
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 Okay, that's all I had. I don't know.
Okay. Any others? If not, we'll get into the lecture because there's quite a bit of stuff to go over. Okay, so stop sharing. I'm going to share. Yeah, I gotta go to the.
Sorry, baby boy. Come here. Baby.
Okay, probability. This lecture that we're doing with quite a bit of information, but I'm going to try to keep it simple. Okay, probability. It's just it can be defined as possible outcomes to total outcomes. Okay, think of it that way. You can define probability in terms of, you can say in ratios, you can say 1 out of 4, you could say 1/4, you could say 0.25, you could say 25%. They all mean the same thing. They're all the same probability. Usually on these problems, you'll be given, it'll say, what is the percent probability of doing this? Or what is the proportion probability or something like that. It'll tell you what unit to put it in, or what way to put it in. Okay. So the first one, you've got a little spinner, and you can divide, this is divided into 8 different equal is the key here, segments. 2, 4, 6, yeah, 8 segments, and then they're all numbered. So it's asked for what's the probability of getting spinning a 4. Well, you look on this thing, you see, well, there's 2 4s, right? So 2 out of 8 opportunities to get that 4. Does that make sense? And so that's 2 out of 8. That reduces down to 1 out of 4. So the probability is 1 out of 4, or 1/4, or 0.25, or 25%. It all means the same thing. Does that make sense?
Yeah.
That's what you have to understand, okay? That probability can be in different forms. You can call it by percent, you can call it by fraction. It doesn't matter. It's all the same thing. And what you should have learned so far is that these are all the same thing. 1 out of 4 is the same thing as 1/4, which is the same thing as 4 into 1, which is 0.25, which is the same thing as 0.25 times 100, or 25%, right? It's all the same thing. Okay. Next problem. Ricardo and Scott use the same spinner. Why that feedback is. They kept the track of the numbers that they got on each spin for 20 spins. And here we're talking about experimental probability. And this is just experiments. That's what the word implies. It's just real tries, okay? So they spun this thing 20 times. When they spun it 20 times, these are the values they got, okay? So the question is, based on this, what's the experimental probability of spinning a 4? Well, in this one, you've got to go up and actually add all your 4s up. Every time you got a 4. In this particular case, they got 6 4s. If you add up all the 4s, it would total 6. So now it's 6 over a total of 20 spins. 6 over 20 is 3 over 10, which is the same thing as 0.3, which is the same thing as 30%. So the experimental probability was 30%, even though the theoretical probability is 25%. But that's okay. That's the way life is, right? It's experimental.
Yeah.
Doesn't always be the theoretical, right? Unless you spun an infinite number, then it would be equal. Well, obviously you can't spin an infinite number, so it's a finite number, so it may not be equal. Okay, does that make sense? That's the difference between theoretical and experimental probability. That's it in a nutshell. Okay, so I'm going to move on to the next page. So yeah, take notes or do something so that this sort of makes sense to you. Okay, I realize there's a lot of stuff here. Okay. Okay, next page, and we'll just look at a couple. Okay, so and we'll just go over the ones that you have to go over. Let's do number 1. A game has 50 wooden tiles. Players draw tiles to spell words. If 20 of the tiles are marked with vowels, what's the probability of drawing a vowel from the tiles? Well, the probability is just going to be 20 over 50, right? Because there's 20 vowels. So what's 20 over 50 reduced down to? As far as a fraction form, what would that be? 20
Like
over,
1/5.
it'll be what?
1 over, 1
Well,
over 5.
No, 1 over, that would be 10 over 50.
Oh, gotcha.
Stupid.
So if you had 20 over 50, what would you have? I'll just show you really good. Yeah, exactly. You just have 2/5.
That's what
Do it right here. So we said 20 over 50, right? That can always be reduced down. I can divide the numerator and denominator by 10, which I'll do. So 20 over 10. This is how you would do it. Okay, 20 over 10. And I have to divide the denominator by 10 also, since I divided the numerator by 10 in order to keep the same fraction, right? So this is what you would do. So it looks like this. So the 10s cross out that 0, so you end up with 2 over 5, right? So the probability is 2 over 5. And what would that be in decimal form? 2 over 5 would be what in decimal form? In other words, you have to divide the 5 into 2, right? Remember that? How do you do that? I'm going to do it really quick. See it?
2.5.
It's point something. I'm using my right hand, sorry, and I'm using my mouse.
I got 2.5.
No, not 2.5 here. So
5
5
divided
doesn't
by
go,
2.
okay, 5 doesn't go into 2, right?
No, but
it's
I
0.
just did it. 5 divided by 2 equals, that keeps telling me 2.5, my calculator.
You're going backwards though. You're going upside down.
Oh, okay.
You're going 2 into 5.
Oh, 2 divided by 5.
Okay, so now it goes 5 into 2. So now 0, you got a 20 down there because I brought down the 2 and then brought down the next number. So it's 5 into 20. How many times does 5 go into 20?
4.
Goes 0.4. So this whole thing is equal to is equal to 0.4, right? Then the very last part of it, how do you convert that into percent form? What do we do with a decimal?
I'm doing
What do we have to do?
it. Times 100.
Thank you. Very good. Times 100. So it ends up being 40%. Right? Does that make sense? So 2/5 is equal to 0.4, which is equal to 40%. They all mean the same thing. Okay?
Mhm.
So we all good on that?
Yeah.
Okay? So I'm going to stop sharing. We'll go back and do one more on that page. That's how you have to do these, okay? I want you to understand that. Okay, let's do another one that you have to do. Look at number 5. A spinner has 6 equal sections numbered 1 through 6. What's the probability of spinning either a 5 or a 6? How would you do that?
Isn't about the same.
They'd be the same, but I want to know what the probability of spinning either of those is. So what that means, I'm going to share with you. Okay, we're back to this board here. I'm going to clear it. Come on here. Clear. This time you got a spinner. You got 1, 2, 3, 4, 5, 6, right? I'm saying what's the probability of spinning a 5 or a 6 at the same time? I mean, either one, excuse me, on the same spin.
1 out of 6.
Not 1 out of 6. That would be if it was a 6 or a 5.
Oh. Gotcha.
So what would it be then? Of getting either one of these. It would be 2. So it would be 2 out of 6. Does that make sense?
Okay, that makes sense.
Okay, 2 out of 6. And then we do the same thing. We reduce that down. What's 2 out of 6 in the lowest common factor form?
1/3.
1/3. Thank you. Now, what's 1/3 in decimal form?
0.33333.
Thank you very much. 0.333 keeps on going. And then what's that in percent form?
33.3.
Perfect. Okay, that's it. Okay, that's what you have to do. Okay, does that make sense to everyone?
Yep.
Okay, so it was 2
You
on
found
this.
2 just because they were just asking of the 5 and the 6, right?
Exactly. That's why you did 2, because it could be either one of these guys, right?
Right.
So if I would have said, what's the probability of getting a 1, 2, and 3? What would that be?
be 3/6.
Exactly. Which
Okay.
reduces down to 1/2, which reduces to 50%.
Okay, got
That's
it.
how you do that. Does that make sense?
Yes.
Okay.
Yeah,
so
that
this-
was, I like that kind.
You'll like that kind. We'll see if we can get more of that kind, okay?
Yes, that's what yeah.
Okay. Okay, so that's how you do that. I think that's all I'm going to share on that page. Because we got to go on. There's more, but that's how you do all these. They're all like that, right? Okay, I'm going to go on to the next page. Stop sharing. There's quite a few to go over. That's why I'm sort of
Independent.
okay. Dependent and independent probability. Excuse me. Dependent probability would mean one outcome depends on the other outcome. Independent, they don't care. The first example here is you got 2 quarters. And so they're asking you to Brad tosses 2 quarters into the air. What's the probability that both will land so that the heads sides are showing? You do quarter number 1, boom, you flip it. You have 2 opportunities. It's either going to be a head or a tail, right? It's going to, that's, so quarter number 1 is going to end on a head or it's going to end on a tail. Then the second, then you flip it again, or they flip the other quarter, and it can land on a head or a tail, and a head or a tail. So there's only one of these 4 opportunities where you'd get a head and a head. So in that particular case, it would be 1 out of 4. Does that make sense? See, the options: head and a head, head and a tail, tail and a head, tail and a tail. There's only one opportunity where you'd get.
Oh,
So
gotcha.
it really ends up. It's like taking the 1/2. Each time you flip a coin, it could either be 50% head, 50% tail. So it's 1/2 times 1/2 gives you 1/4. But this is graphically how you would show that. But the answer would be 1/4. They go ahead and show it. They multiply to find the probability. Multiply the 1/2 times 1/2 is 1/4. Okay, does that make sense?
Yeah.
Okay, now
Yeah.
here, but this would be independent probability. They're both independent of one another. This one is dependent. Here, you've got 6 marbles in a box. Okay, 4 are blue and 2 are red. Okay. Where the heck's the red one? I know it says 2 are red. Anyway, so it's 4 one color and 2 the other. Assume that the first marble selected is blue. Okay, so we took out a blue. Now there are only 5 in the box, and 3 are blue. The probability that the second marble would be blue would be 3 out of 5 because you've removed 1 marble, right? This particular case, you started out with 6 marbles. Now you got 5 marbles. So the first one to get a probability of a blue is 4 out of 6 or 2/3. And then, and the second probability of getting a blue would be 3/5 because there's only 3 blues left. So 3 out of 5. So then you'd multiply them together. Multiply to find the probability of the 2 events. 2/3 times 3/5, which is 6/15 or 2/5. So the probability of getting both marbles blue would be 2 out of 5. Okay. You just have to think about that for a while. I mean, I realize it probably doesn't sink in right away. But that's the example. Now let's look at, see what I want to show you here. Look at this page here. Some of this stuff I'm going to have you ignore because it doesn't make any sense the way it's presented. Okay, so here's some problems, and let's look at the ones that you're assigned. Okay, number 1, Kim rolls 2 standard 6-sided die. What's the chance of both will be 4s? How would you do that? what's the chance of, you take one die, you roll it, it's got 6 values on there. What's the chance that it's going to land on one of the sides?
1/6.
1/6, exactly. Okay, so now you take that same die, you roll it again. What's the chance that it's going to land on the 4 again?
1/6
It's
again.
1/6, but the composite probability is going to be 1/6 times 1/6. So it's 1/36 that you could take one die, roll it once, get a 4, roll it again and get a 4. That's only going to show up 1 out of 36 times, theoretically. That makes sense? I'm just multiplying the two probabilities together. The 1/6 times the 1/6. Okay?
Okay.
That makes sense for everybody?
Yeah. Mm-hmm.
Okay, what about number 3? A spinner has 4 equal sections. 2 sections are red, 1 is green, 1 is blue. If the spinner is spun 3 times, what's the probability that all 3 spins will be red? So you've got 2 reds, 1 green, and 1 blue. So the first time, what's the probability of getting a red?
2 out of, what is it? 2 out of,
2 out of 4. Yeah, exactly. It's 2 out of 4, right? Or 1/2. So if you spin this thing 3 times, so it was like this, right? It was red, red. I don't know what it was, but come on. Stop sharing that.
Red, green, and blue.
Okay, thank you. So Emily or whoever answered that question was right. It's 2 out of 4 that you would get a red, right?
Mhm.
Right? On one spin.
Yeah.
Which reduces down to 1 out of 2. Okay? So we're saying we're going to do this 3 different times. So the second time, it's the same probability. You're going to get 1 out of 2, right? And the third time, you're going to get the same probability 1 out of 2 because you're not taking any of them away. But now it wants to ask, what's the total probability of getting a red, red, red in all 3 spins? You just multiply these fractions together. So it's 1/2 times 1/2 times 1/2. Okay? And what's 1/2 times 1/2 times 1/2? What would that be? What is it?
I don't even know how to do that.
You
It'd be
don't? Okay, well, it's okay.
1/8.
You-
5 times 0.5.
More fractions.
yeah, but I do it in fractions. I've got it's
Yeah.
1 2 times 1.
So this is what I always do, is I always do 1/2 times 1/2 and figure that out that answer, and then I times it again by the other half. Is that
That's
right?
fine. Yeah.
Okay.
You could say 1 times 1 times 1 on the top, the numerators, right? I mean, it's the same thing,
1.
right?
And then 2 times 2 is 4. 4 times 2 is 8.
Yeah, exactly. Whoop, that should be a.
So it can't be that easy.
It is that easy. That's the point.
Okay.
It's just I just can't seem to do this right here. But yeah, no, that's the point. So
Okay.
it's this all divided by 2 times 2 times 2. And like you said, that's 2 times 2 times 2 is 8, right? It's like that.
So when times in fractions, you can go straight across. You don't have to go diagonal.
Exactly. No, you are going straight across. That's what you're doing.
I didn't know. Okay, for some reason I'm stuck on like we have to go
No,
diagonal.
you're just making it too
Okay.
hard. Yeah. So
Yeah.
it ends up being 1/8, right?
Mm-hmm.
Right?
Yep.
So now
Right.
if I asked you what's that in percent? What's that probability 1/8 in percent? I want to
Isn't it like
convert it to a percent. What's that?
12.5%?
12.5%. Very good. You take the 8, divide it into 1, and you multiply it by 100. And you get 12.5%, right? It means the same thing as 1/8. That all makes sense?
Yeah.
That's how
The only thing
that's
you
how
have
you
to-
do these. Don't make it more
The only thing
complicated.
that doesn't really make sense to me is, let me make sure I got this right. We got 3 1/2 because
Yep.
of the 3 colors.
Yes. Well, because
Okay.
2 are red,
Right, so
That's
that
why.
counts as 1.
so the opportunity of each one of getting a red is really 1 out of 2,
Right.
right? And then we're going to do this 3 times in a row. And so it's asking how
Okay.
many, what's the probability of getting a red on all 3 turns? That's where you have
Oh,
to
because of
multiply.
the 3. Okay, I forgot that part.
So
Okay.
1/2 times 1/2 times 1. That's how we did that. Okay.
Okay. Got it.
Everyone understand that?
Yeah.
Okay,
Mhm.
we'll move on. Okay. That's how you do these. Okay. And you know, I'm trying to teach a whole statistics course in one day, which is really really
Mhm.
hard. So obviously, we're not hitting all, we're just hitting the highlights. Okay. That's how you do these. Let's look at number 7 so we make sure we know what we're doing here. What's the probability of rolling a 5 and then spinning an even number? So what does that mean? We're looking at this little chart up here, right? This spinner. First of all, the probability of spinning a 5 would be what?
1/6.
1/6. Very good. And then what's the probability of spinning an even number?
What is it? 2/3.
1/3.
No. How
1/3.
many? Well, how many even numbers do you have here?
1, 2,
Yeah,
3.
3.
And then how many total?
6.
6. So 3 6 is 1/2, right?
Mm.
So now you've got 1/6 times 1/2, right?
Let's see.
Right?
1/12.
1/12. 1/12 is the answer. Okay.
Okay.
A is the answer. Okay. Okay. I'm going to move on. Okay. That's okay. 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 Next page. Okay. Combinations. And we're not going to do the first part of it. That very first page of homework, I said delete it. Don't worry about it. It's okay to understand this, but you really have to use some higher math to solve this, even though they do little tables and it doesn't make any sense. You're not going to do this. So you can do it in this simple one, and that they show a very simple one here. One type of an item where they show Pablo is shopping for fruit that sells apples, bananas, grapes, and pears. He's buying 2 different kinds of fruit. How many combinations can he buy? You can put it in a little table like this, where you've got apples, bananas, grapes. There's only 6 different combinations of getting those 2. Okay. But there's a mathematical way of determining that, but I'm not going to show it to you because it's into factorials and things that you don't understand. I don't want to confuse you. So this is just a simple little form of determining something where it was 2 out of 4. It would be 6 options. Okay. I won't give you this on the test. Okay. I'm just telling you right now. So we're going to stop sharing and we're going to look at that next page. Come on. And 301. And I'm not going to give you this either. Forget this. This practice 4.1. These things are ridiculous to do these things. Anyway, so just don't worry about it. 401.
Page 301, we don't need to do any
Don't need
work
to
on.
do 301. Just get it out of your head. Don't even worry about it. Yep. So I'm just showing you that to let you know that don't worry about it. So I'm going to move on to the next one. Yeah, it's just anyway. Okay, 302.
You don't got to tell me twice.
Okay. So now it's combinations with more than one type of item. And here what you can do is we have an opportunity. We've got 3 shirts, 2 pair of pants, and 2 pair of shoes. And it's asking, what are the different combinations can you get? Well, if you do it pictorially out this, you'll end up getting 12. There's 12 different different, there's shirt 1, pant 1, and shoe 1. And then there's shirt 1, pant 2, and shoe 2, and it keeps going and going, okay? But you can do this mathematically, and mathematically is right here. Start with the shirts. Each shirt, that's 3 times 2 is 6. Additionally, for each 6 option, 2 options for shirts. The bottom line is you'll end up with the number of shirts is 3, number of pants is 2, number of shoes is 2. If you multiply these all together, you get 12, just like you'll get in this diagram. Okay. So most of these problems are just going to be like that. So I'm going to stop sharing that. We're going to go to the next page. Again, you're not going to learn how to do all the statistics in this one day course, because it's not going to happen. Now, all these problems, you can use just what we did. You can just use the formula of taking the number of each and multiplying by multiplying it all up to get the product. So look at the first one. Frank is making a sandwich. His sandwich will have 1 type of bread, 1 type of meat, 1 condiment. He has 4 breads. He has 3 meats, and he has 4 condiments, right?
Yes.
So how many ways can Frank make his sandwich? You're going to multiply them together. It's going to be 4 times 4 times 3, which is 16 times 3, which is 48. So we've got 48 options of doing that. That's how you do that. Okay, we'll do one more. Okay, does that make sense? So 4 times 4 is 16 times 3 is 48. So let's look at Henry is wrapping a gift for his daughter. He used 1 type of wrapping paper, 1 ribbon, and 1 bow. He has 3 different types of wrapping paper, 3 different bows, and 3 different ribbons, right? So if that's the case, how many different ways can you wrap the paper or the gift, excuse me? What would that be?
7?
No. I'm going to share. I'll share with you. So.
Am I timesing the 1 times 1 times 1 as well?
No.
Okay.
I'll show you.
And I'm off.
Yeah, I see where you're going. No. Okay, in this particular one, there's 3 ways for wrapping paper, right? Okay, and there's 3 ways for the bow, right?
Yeah.
There's 3 different opportunities, 3 ways for the bow, and then there's 3 ways for the ribbon, or what was it? I can't remember.
3. God, he has 3 different types of wrapping paper, 3 different types of ribbon, and 3 different types of bows.
Okay. Ribbon. That's spell ribbon. I don't know. So there's 3 each one. So all it is so combinations. Yeah, there's no fractions involved. I want to make sure. It's just equal to 3 times 3 times 3.
Equals 27.
Is equal 27, exactly. That's your answer. Okay. It's like
Not
that first
what I
one. There's no fractions ratio, okay?
said. Okay.
Just so I don't want to get you confused with that. Okay, so that's how you do that. And the first one was the same way. We just multiplied those 3 different ways, right? I can't remember what the problem was, but that's how you do it. Okay. Okay, so let's move on. Share. Okay, now we're into permutations. Okay. Permutations are different than combinations. Permutations, you usually always have more because it's a sequence of events. Okay, and taking all these opportunities, but it's putting them in a certain row. Like we didn't care about the wrapping paper, whether you counted the wrapping paper before the ribbon, before the whatever. But in permutations, you do. It's the order. Okay, so it ends up being more. There's more sequences than combinations. Okay. but it's the same, simple permutations are the same idea. So if you, let's example one. Okay, Liz is playing her day off. She wants to visit the art museum, try new coffee, call her mom, take a walk, but not necessarily in that order. How many options, how many possible sequences of those 4 activities do you have? Well, it ends up being you just take the 4 times the 3 times the 2 times the 1. It ends up giving you a big number, right? It's like 24 in this case. So there's 24 different permutations to do those 4 things. 4 different, right? There's 24 different ways that you can do those 4 things in a day. And obviously, in your mind, you narrow it down to 1 and you do it. And you don't think about the permutations, but that's how you do that. Look at example 2 here. There's 10 runners are competing in a race. There are prizes for first, second, and third place. How many possible sequences of top 3 prizes are there? Okay, if you were giving a prize to everyone, if everyone got a prize, then you'd have to count all 10 and would be 10 times 9 times 8, just like this. It would be a big number. So it's called 10 factorial. 10 with a little explanation mark means 10 times 9 times 8. But that's not the answer here, because what we want to know is there's only 3 of these people that are going to get first, second, and third prize. So we only care about the top 3. So what it boils down to is just you take the 10 times the 9 times the 8. So there's 720 possible ways that the runners could arrange to have the top 3 prize winning slots. Note that simply multiplying by 10 by 3 won't work, okay? It's 10. The first opportunity is 10. Then there's only 9 left, so it's 9. Then there's only 8 left, so it's 8. And you don't have to go any further, okay? Does that make sense?
That one does, yeah.
Okay.
Yeah.
Okay, so let's stop sharing that and we'll look at some of the, okay. See what's next here. Sharing that, share. Okay, look at some of the problems we have. Okay, let's look at number 1. Naomi is trying to remember the password for her email. She knows that it has the following characters: MQ, $, L, and 7, but she can't remember the order. How many possible sequences for those 5 numbers? Well, just list them. So I'm going to share my screen here. Just so you, and I'm going to show you.
So it'd be 5 times 4 times 3 times 2 times 1.
That's exactly what it would be. And I just want to show you why that would be. I mean, just so you can see it. Hopefully see it. But yeah, exactly. That's what it would be. And then a 7. So the first so it could be, it could be one of the 5 will be an M, right? So if you take a M, M's going to be 5. M will be 5 times. Well, once you take M out of the way, you've only got 4 opportunities left. So that means the next one, you don't know which order, but Q, if you took it Q, Q would only have 4 opportunities, right? Q or one of these other, so it's going to be 5 times 4 times 3 times 2 times 1. Anyway, that's what it's going to be. So what's 5 times 4 times 3 times 2? It is 5 times 4 times 3 times 2. What's 5 times 4 is 20, right? What's 20 times 3?
12.
No, 20 times 3.
Oh, 20 times 3?
Yep. 60. And then 60 times 2?
120.
120. Boom, that's your answer. That's the number of combinations you would have, or permutations you would have, right? Because order is the important thing. It's just not scrambled. I mean, it's just, okay, so all these permutations are just like that. You're either multiplying all of them or you're taking 2 or 3 of them out of the the whole group and multiplying it. Just like we did with the area where we had 10 runners, only 3 received prizes, so it would be 10 times 9 times 8, right? Okay. So, okay, look at, let's go down to number 5. Soraya had been given 6 tasks to do the work, but she has time to complete only 4 of them. She must decide in what order to do the tasks. How many possible orders of 4 tasks are there? So she's got 6 tasks to do, but she has time to only do 4 of them. Six times 5 times 4 times, I think it's 30 times 12. It's going to be 6. It's going to be 6 times 5 times 4 times 3, and you're not going to worry about the 2 and the 1. What's 6 times 5 times 4 times 3?
Okay, 6 times 5 is 30. What was the next one?
Times 4.
Times 4. That would be 120.
Okay.
Could be the treat.
And then times 3.
360.
360. Boom. Is 360 one of the answers?
Yep.
Yep, well, that's what it is. Okay. That's how you do these. Okay.
Oh,
Okay, let's go on to the next section. Start share. Okay, now we're into comparing proportions and so we're done through statistics. See how we did that? We did the whole thing, and there's a lot of information there. Just take those simple problems and understand how to do the simple problems. Okay, don't make it any more complicated. Okay, so now we're on to comparing proportions in different formats. And that's what we have a format here, which is just a bar graph, right? The bar graph shows the number of accidents for men and women aged 18 to 35 in a particular county for the summer. The following year, the county released a report that monthly rates for 2015 had been 1.6, 2.3, and 1.8 times that of the women for June, July, and August. Okay, of the 6 month report, when was the accident? Okay, so it gives us information down here. So the question right here, of the 6 months reported, in other words, 2 Junes, 2 July, and 2 August, when was an accident victim more likely to be male? Well,
July.
it's right here, right? It's July, right? That's not so, Determine the proportion of 2014 male accidents to female accidents. So we look at 2014 male.
or 50.
Yeah, you've got to,
100.
you have to add them up, right?
Yeah.
So what you want to do is take the male, 350 plus 450 plus 200, right?
Mhm.
Is that right? Oh, they're doing each one individually. I see what they're doing.
Right.
For June, they're taking a ratio of men to women, July men to women, and then August men to women, right? And so they're getting
Okay.
1.75, 2.25, and 2. Compare the calculated values to determine the greatest proportions of male to female. The highest value is July, because July was 1.75. Though this ratio of men to women is the greatest ratio, right? For these 3 months. That's
Right.
just that's just one way that you could use this data. That's all they're showing you, really, right?
Mhm.
That makes sense?
Yeah.
You have to sort of figure out what they're trying to do with this information, but the point is using the data, right? We'll see what they have on the next page here. Stop sharing, share. Okay. Okay, example 2. Here's a velocity time graph. It shows the rate of acceleration of 2 classic muscle cars. A new model, the Hermes, is able to accelerate from 0 to 60 per hour in 8 seconds. Okay. So this is not the Hermes, this is 2 other cars. How does the Hermes compare to the cars on the graph? So you have to, you want to figure what the rate of acceleration is. So it's miles per hour divided by seconds. So in other words, you go from 0 all the way up to 80, and that's over a 10-second period, right? So look at down here for pony's acceleration, it's 80 divided by 10, 8 miles per hour per second. And the fireballs this one right here is 70 divided by 10, or 7 miles per hour per second. Right, the rate of acceleration of the Hermes is the same way. They give you the value. They say it's 60 miles per hour in 8 seconds. So it's 60 over 8, or 7.5. So now you can compare numbers. You've got an 8 miles per hour per second, a 7 miles per hour per second, and a 7.5. So the Hermes is faster than the fireboat, but still slower than the pony. Okay, do you understand this? We're just using this data on this graph to compare it to some other data that's not on the graph. Okay, that's what we're doing. Okay. Do you see that? Do you understand this part?
Yeah.
It's like pony's acceleration is 80. It goes up to 80 miles per hour. It takes 10 seconds to do it. So it's 80 divided by 10, or 8 miles per hour per second. These are the units for acceleration. Okay, it's distance divided by time times time. In the time in this case is hours, and it's also in seconds. Okay, anyway, let's look at practice 10. Compare the proportional data in the following scenarios. Okay, you got 2 graphs showing domestic and foreign sales for a brand of U.S. potato chips. For which year were the foreign sales higher as a percentage of total sales, and what was the difference? So you've got 2 years here. You've got 1975 over here on this circle chart, right? And you've got on this bar chart, you've got 2005, you've got data. So you'll want to compare the two. I think they probably do it on the next page, unfortunately. Stop sharing that and share. Okay, stop share. I lost my. I look at both at the same time here. Just a sec. So this is 308. So well, I guess that number. Lord, it looks like it's missing something here. Okay, I'm gonna go back, sorry. So this one right here. Okay, so back to this thing. There's enough information to analyze this to determine how to answer the question. You got 1975 data, you've got 2005 data. One is in a circle. And so if you look at this, domestic is the larger one, Foreign is a smaller one. So this is about 1/4 of this whole graph, right?
Mhm.
This is about 25%. So 25% of the sales of brand X
Oh.
was foreign, right? 25%. This one over here, it shows in 2005, it shows foreign and it shows domestic. Well, it's a different scale, right? Domestic, you've got 5.5. Foreign, you've got 2.5. What's 5.5 and 2.5 added together? What's 5.5 plus 2.5? It's 8, right? So foreign in this case is 2.5, 2.5 over 8, right? Take your calculator and tell me what fraction or what decimal is that? What's 2.5 divided by 8? 2.5 divided by 8. I'm going to share this one right here.
It's
What do you
like
get?
31%.
Okay.
I'll say it's 0.3125.
Okay. We'll just go. It doesn't matter, but the point is it's over 30%, right?
Yeah.
That's 2005. The other one, I mean, this is how you have to interpret these graphs. The other one is circle, and it's about 1/4. And so what's 1/4?
25%.
Yeah, it's 0.25 or 25%, right? So therefore, the foreign amount went up to 31 from 25. That's how you'd interpret that graph. Those two graphs. Okay? That's all you're doing there. Okay.
Oh, okay.
Now we'll look at the last page. Stop sharing that. Share. Okay. Okay. Let's look at number 3, okay? So again, you've got this is a brake test, so it's deceleration. It's speed divided by time. So instead of accelerating, you're decelerating, you're stopping, right? So engineers and automotive parts company are testing brakes to find out whether their brakes beat those of their competitors. So it's deceleration. So which decelerate the same car, which can decelerate the same car at a rate of 15 miles per hour per second? Which statement correctly describes the result of their latest tests? So, so you've got the test up here. So it goes 50 into 3.5 seconds. So this is the actual brake test. So we want to know, is this greater or less than 15 miles per hour per second? So if you took the 50 divided by 3.5, what do you get?
50.
So go here. You got 50 miles an hour, miles per hour.
It's about 14.3. Well, it's 0.28, but
It's
14.28.
14.2, okay. Per hour per second. When I used to work in the auto industry, way back when, I worked with decelerometers. We'd place them on dummies, and we do these barrier tests, figure out what the deceleration rate is. So I sort of understand what they're talking about here. So this is just miles per hour divided by seconds. So it's an acceleration, but it's a negative acceleration. So this is what that graph tells us. So we compare that graph with the other piece of data, which was 15, right? Miles per hour per second. And so then we have to, then we pick one of the answers. So that, I'm gonna go back to the question. So I know it. Share the screen. Go back to this thing here. So we're looking at this. What we're looking at. We figured out this one was 14.2 I can't remember what the number was. I don't have it in front of me, but anyway, it's less than 15, right?
Mhm.
Okay, I want to make sure I know which is which. The same car at a rate of 50 miles per hour. Which statement correctly describes the results of their latest test? Okay, the brakes that, so the test is up here and it's 14 point, it's less than 15.
Mhm.
So the brakes are worse or the brakes are better than the competitors? Or this must be, is that the competitor? Which is the competitors? That's what I'm,
I have no idea.
that's, I can't read this right. Engineers are testing brakes to find out whether their brakes, okay, which can accelerate the car rate of 50 miles per hour per second. Which statement correctly describes the result of their tests? I think this is their tests. So there, it ends up being less than 15. So the brakes are better than the competitors by less than, yeah, by less than 1 mile per hour. So I think it's B because it was 14 point something, right?
Yeah.
Anyway, again, this is how you use this data. Okay, you have a graph and you translate that into a, a result, and you compare that with whatever else is in the story problem. Okay, that's how you do that. Okay, questions on that? This is just how to, this is just more analyzing data is all it is, using graphs or pie charts or whatever, right, to do it. That's all we're doing here. Okay, I think we're going to take a 20 or 10-minute break. Okay, and I'm going to stop the video and we'll come back and then we'll go back slowly and we'll try to answer more of those problems. Okay, in this, on today's session. Okay, so take a break. Okay, and I'm going to stop sharing that. And I'm gonna, okay, I'm gonna